Hello and welcome to this course. Thanks for enrolling and I'm really glad to have you here. Now if you are coming from my previous course, I want you to know that the only reason I've made this course is for the support and motivation which you have given me. And if you are someone new, my name is Febin George and I have been a programmer from several years with 3 years of professional experience. In this course, you will be learning the Python implementation of 4 pillars that hold together the object-oriented programming, which are abstraction, encapsulation, inheritance, and polymorphism. Let's take a look at our course structure. We will first start off by installing Python on your machine, whether you're on Windows or Linux or Mac. Now this is an optional section if you already have Python installed in your system. And then we move on to classes and objects, which is the underlying structure of object-oriented programming. And then you will learn about attributes and methods which constitute a class. And then we move on to the first 2 pillars of object-oriented programming, which are abstraction and encapsulation, and on completion of that we start with the third pillar of OOP, and it is also the most commonly used one, which is inheritance. And then we move on to the final pillar of object-oriented programming, which is polymorphism. And on completion of all these concepts, you will implement a final project in which you will simulate a banking system by making use of all the concepts which you will be learning in this course. And as a prerequisite for this course, you need to be familiar with the basics of Python, such as variables, data types, functions, etc. Now in case you're not familiar with these topics, don't worry, I already have a free course on this one. I would suggest you first take that course on basics of Python and then come back to this course. So let's get started with the first section to install Python on our machine, and in case you already have it installed, you can move on to the next section on classes and objects. I'll see you there. Thank you. Hello and welcome to this lecture. In this lecture, we will be setting up our development environment on your Windows machine and writing your first program in Python. Now if you are a Mac or a Linux user, you can skip this lecture. I have created separate lectures demonstrating the installation for a Mac as well as a Linux machine. Now we will be installing Python 3 as well as a text editor. Now the installation of a text editor is completely optional. You might as well use the notepad that comes along with your Windows machine, but I personally prefer the interface that the Atom editor has to offer, which we will be installing in this lecture. So let's get started by opening our web browser. The one which I use is Google Chrome. Go ahead and open it. In your address bar, enter python.org and scroll down and you will have an option that says Python 3.6.1 for download, which is the version at the time of creation of this course. Click on it and then scroll down below. You will have an option for a Windows download. So check for the operating system Windows and select this executable installer that says Windows x86 64. That will make sure that it gets installed on your system whether you're on a 32-bit or a 64-bit operating system. Click on it and your download should begin. So once your download has been completed, click on the downloaded executable file and then your installation of Python should begin. Click on run and then click on this checkbox that says add Python 3.6 to path to execute your Python files from command prompt. Now click on install now and that begins your Python installation. Great, our Python installation has now been completed. Click on close and now we will go and install our Atom editor. To do that, on your address bar enter atom.io, which should open Atom's homepage, and there you will have an option for download for whichever operating system that you're in, whether it's a 32-bit or a 64-bit. Click on download and that should begin your download for your Atom editor. Our download has now been completed. Go ahead and click on the downloaded executable file and that should begin the installation of Atom editor. Click on run when prompted. So once your installation has been successfully completed, you should be on this window of your Atom editor. Great, so we now have our Python as well as the text editor set up on our Windows machine. Let's go ahead and write our first Python program, which is hello world. Let me first get rid of all these tabs. Now there are multiple ways in which you can execute a Python program. We will be sticking on to 2 ways throughout this course. First one is to execute it through a text editor and another one is to execute it through idle environment, which you will be looking at shortly. So you need to use a text editor when you're writing complete Python programs, which you can execute multiple number of times. To write your program, first open a new file, click on file and then new file, and then save this file as a Python file. To do that, click on file, click on save, and then you could give any name as per your choice. I will be naming my file as hello world and then end it with an extension .py to identify your file as a Python file. And once you do that, that, you can now start writing your Python code. So what we're going to do in this program is to print a string hello world onto your monitor. So in order to do that, Python has a function called print. Now don't worry about these functions and strings. All of this will be dealt in the upcoming sections in this course. So for now, just type this line of code into your system, which is print, and open parenthesis, and then enter a pair of double quotes and enter the string hello world. Once you do that, save this file and execute it from your command prompt. Do that, open your command prompt by heading over to start and typing cmd, click on it. Now what you need to do is enter py space the path to your file. Now I have saved my file in my desktop, so it would be desktop and then give a backslash and the file name, which is hello world.py. Now on pressing enter, I will get the output as hello world. This is one way in which you can execute this program. Another way is through the Python's idle environment. To do that, click on start and type idle, and then click on this executable file. Now this is Python's idle environment, which is an interpreter that gives you output on the fly. So if you want to print hello world in the idle environment, all you have to do is print hello world and you have your output. So I will be continuing my execution on my Mac machine, but if you have got these two working, which is to be able to execute through a text editor and the Python's idle environment, then you should be able to follow along with me. But one important thing that you need to remember is when you execute your Python program through your command prompt, you need to enter py. Now on my Mac, I will be entering Python 3, but on Windows that command is not recognized. On Windows, what you need to enter is py. So that's the end of this lecture. You have now set up your development environment on your machine and you have written your first program in Python. If you have faced any issue in this installation, put it up on the discussion board and I'll help you from there. Hello and welcome to this lecture. In this lecture, we will be setting up our development environment in a Mac OS. If you're a Windows user or a Linux user, you can skip this lecture. I have created separate lectures demonstrating installation for Linux as well as Windows, and you can watch whichever is appropriate for you. Now throughout this course, we will be needing Python 3 as well as a text editor. Now you can use any text editor of your choice. You could even use the basic text editor that comes with your Mac, but I personally prefer the interface of the text editor by name Atom, and in this lecture I will be demonstrating how to install Atom as well. So let's start by opening our browser. The one which I use is Google Chrome, and head to python.org. Now head to the download section and click on whichever version of Python 3 is available. At the time of recording this video, the version available is Python 3.6.1. Go ahead, download it, and once it is downloaded, click on the installation package. Over here you can feel free to read through all the license agreements, but I'm just going to hit continue and click on agree. And if you would like to, you can change your installation directory, but I'm just going to install it in the default directory, and just enter your admin password when it prompts you to and click on install software. So this might take some time. I'll edit the video here and I'll get back to you when it is done. Alright, so now that our installation has been completed, let's just close this window, and you have an option to move your installation package to trash. I'm moving it to trash since I no longer need it. And then let's just verify if Python has been installed. So what we will be using throughout this course to learn the concepts is Python's idle environment. So in order to check if that has been installed, hit a command space on your Mac and enter IDLE and hit enter. So if this opens up fine, it means Python has been installed in your computer without any problem. Yes, it does open and we are good to go with Python. So next what we need is a text editor. As I told before, I will be installing Atom in my system. You're free to choose whichever text editor you prefer. So let's once again open our web browser and this time enter atom.io, and here head over to the download for Mac option, and once your download has been completed, you will have an option to extract it. I'm editing this video here. I'll get back to you when the download is done. Great, our download has now been completed. Go ahead and click on the downloaded file. Now that should extract your Atom package and should give you a executable file. Now double click it and that should open the Atom editor for you. So click on open. Great, so that opened the Atom editor for us. Now that we have Python and the text editor installed, let's go ahead and write your first Python program. Now by convention, the first program that you write in any programming language happens happens to be the hello world program. Let's write that on our Atom editor. So first, save this file as a Python file. To do that, click on File, head over to Save, and then enter any file name of your choice. I'm just naming it as hello world. Just make sure that you're ending it with a .py as the file extension to identify it as a Python file. Now, in order to write a hello world program, which is to print the string hello world on the monitor of your screen, you need a function in Python called the print function. So enter print and then open parenthesis and enter double quotes or single quotes and type in hello world. Now all of these are concepts which we will be dealing later on, strings, functions, and all of it we will be dealing in a lot more detail. But for now, for your first program to be functioning right, just type this into your text editor and save this file. Now to execute your Python program, open your terminal. I do that by hitting a command space and then entering terminal. So that opens up the terminal for you, and now what you need to do is enter Python 3 space the path to your file name, which is, I have saved my file on desktop, so it will be desktop / your file name, which is hello world.py, and that gives you the output hello world. Now there are multiple ways to execute a Python program. We will be using two ways in this course. One is through the text editor, which you will be using once you reach the section of conditional statements where you'll start writing your programs in Python. But until then, where you will be executing your Python code will be in the idle environment of Python. So let's execute the hello world in our idle environment. So command space and enter idle. That opens up the idle environment for you, and here what you do is write the string print hello world and just hit enter, and that should print the string hello world for you. So now you know why we use idle. It's because practicing concepts becomes much more easier. You don't have to go through that pain of saving a file and executing it each and every time. So that's the end of this lecture. You now have your development environment on your Mac ready, and you have written your first Python program. The next section is on variables and data types, and from there we will get started with the concepts in Python. I'll see you there. Thank you. Hello and welcome to this lecture. In this lecture we will be setting up our development environment on a Linux machine, and you will be writing your first program in Python. Now if you are a Windows or a Mac user, you can skip this lecture, as I have created separate lectures demonstrating the installation for a Windows as well as a Mac machine. We will be installing Python 3, idle environment for Python, and a text editor. Now the installation for a text editor is completely optional. You might as well use the text editor that comes along with your Linux, but I personally prefer the interface that the Atom editor has to offer, which we will be installing this lecture. So I am running this on an Ubuntu machine, and we will be performing all the installations through command line. So go ahead and open your terminal by pressing Ctrl Alt and T on your. Once that has been opened, enter the command, and that should add a repository into your system. Now if you are on Ubuntu 16.1 or higher version, then you can skip this first step. So enter your admin password and hit enter and add repository. So once that has been completed, enter this sudo. So what sudo does is that it gives you the super user privilege to execute that command, and what apt-get update does is that it updates all your repositories to the latest version from which you install. So once that has completed, enter this command, so get install python. That should begin your installing Python. From press a Y, and great, we now have Python 3.6 installed in our Linux machine. Next what we will need is the Python's idle environment. In order to install that, enter this command get idle. Idle is an environment provided by Python where you can execute command. We will be using idle a lot throughout this course to practice all the concepts which we're learning. So now we have Python and idle installed. Let's go ahead and install the Atom editor. You need to first add a repository. Go ahead and enter this command onto your Linux machine and press enter once again on prompt. That should add repository. So once that has been completed, next what you need to do is update that repository to the latest version by running sudo apt-get update. So once your update has been completed, ignore some of the error messages that is a problem at all. So go ahead and install sudo apt-install add. We will now be installing our press Y on prompt, and so we have now installed all the tools required for you in this course. Now let's go ahead and write your first program in Python. Now there are multiple ways to write a program in Python. We will be sticking on to two ways. The first one is to write a complete program through a text editor, which you can run any number of times as you want to, and another approach would be to run it through the idle environment which we installed earlier. Now
idle we will be using when we need to practice concepts to get immediate result, which you will see when we execute our first program. So in order to do that, first let's execute in our text editor. Open your atom editor, press your Windows key on your keyboard and enter atom, click on the atom. So this is your atom editor in which you will be writing all your Python code. So by convention of any programming language, your first program needs to be a hello world program. Let's go ahead and follow the convention. Write the hello world program in Python. First what you need to do is to file as a Python file. Do that, click on file, head over to save, and then give any file name of your choice. The file which I will be world, make sure that you're ending it with an extension .py to identify it as Python file. I say stop. Once that is done, next what we need to do is to write a function called print that would print hello world on your monitor. Do that, write print, then open a pair of parentheses, then a set of double quotes or single quotes and enter a string world. Now all of these concepts which I spoke about, functions, strings, all of them will be explained much more in detail in the upcoming sections. But for now, to write your first program, go ahead, write this line of code so that you get the output on your screen as hello world. First save file and execute it. You will execute it from your terminal. So back to your terminal, clear by type clear, and then to execute it, type python3 space file name. So for that, give the location to your file. Like how I showed you earlier, I had saved it on my desktop. So desktop / hello world.py, and there we have our out hello world. Next execution which we will be doing is through the idle environment. Open that, hit the Windows key again, enter icon. Now in your idle 3, all that you got to do is to enter print, then hello. Pressing enter, you get the output right on the screen. So that's the end of this lecture. You have your development environment now ready. I will be continuing execution on my Mac, but if you have got these two programs working, then you should be able to follow along with me. If you have faced any issues during the installation, use the discussion board and I'll help you from there.
Hello and welcome to this lecture. In this lecture, you will be learning what are classes and objects. Now before we get started with learning what are classes and objects, let's first understand the need to go for classes and objects. Let's take an example. Say we have a function called calculate salary, which can be called on an employee to calculate the salary of that employee. Now in a normal program, this function can be called on a student as well, but that doesn't make much of a sense, and we want to restrict the access to this function only to an employee and not to a student. So classes and functions help us do that by placing this function called calculate salary within a box, and we seal that box and make it available only to an employee and not student. Now let's understand what are classes and objects. So by the definition, classes are a logical collection of attributes and methods, and objects are instances of class. Now let's try to understand that with the help of an example. Let's say we have this godly power to create a superhero. So first what we will do is describe what our superhero will be like. So we say our superhero should have a red cape and a superhero should be able to fly. And then what we will do is, with the snap of our fingers, we give life to the superhero. Now by relating this to classes and objects, when you describe your superhero, what your superhero should be like, that's what your class does. You give all the descriptions in your class, and giving life to the superhero is what your object does. So at the time of creating an object, you're giving life to a class, which is also called as an object instantiation. Class consists of attributes and methods. Let's see how to identify them. Now when you're just getting started with an object-oriented programming concept, it is pretty simple to understand this concept and divide your program this way. There are three things you need to identify from what you're trying to implement. The first thing is the noun, which is a name, place, or an animal or a thing, which will be the name of your class. The second thing that you need to look for is an adjective, which are properties that further define your noun, which will be the attributes of your class. And the third thing that you need to look for is verbs, which are the actions that are performed by your noun, which will be the methods of your class. Now let's see how to identify them in our example. So in our example, our superhero can be the name of the class, and then we said that our superhero should have a red cape. So red cape is a property that further defines our superhero. So that can be an attribute of our class. And then we said that a superhero should be able to fly. Now being able to fly is an action being performed by the superhero, and that will be a method of the class. And finally, we create an object and give life to the superhero by giving a name for that object, and if you wish, you can name this object as Superman. So now that you've understood what are classes and objects, let's move on to the next lecture, in which we will discuss how to implement implement classes and objects in Python. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, you learned what are classes and objects, and in this lecture, you will be learning how to implement them in Python. Let's get started by opening Python's idle environment. I do that by hitting a command space on my Mac and entering idle. Now if you are on Windows or Linux, you can do the same by pressing the Windows key on your keyboard and entering idle. Now in order to understand the implementation, let's take an example. Say we have a requirement to check if an employee has achieved his weekly target or not. So as I told you earlier, the first thing that you need to check in your requirement is for the noun, which will be the name of your class. Now looking at our requirement, we see that the noun here is employee. So let's create a class for employee. To do that, enter the keyword class all in lowercase followed by a space and then the name of your class. Now the name of your class can be any name of your choice. By convention, the first letter of your class name happens to be in uppercase. Let me just call my class as employee and then provide a colon at the end of it, which denotes that there are a set of attributes and methods that this class contains, and then provide an indentation like how you would do while creating functions and loops, and then start by entering the attributes of your class. Now what are the class attributes? Class attributes are adjectives, which means to say that they are properties that define your class further. So what can define our employee further? Our employee can have a name, let's call him Ben. Our employee can have a designation, let's say he is a sales executive, and then we need to have a mechanism in which we can keep track of the number of sales he has made this week. So let's create an attribute called sales made this week and assign it with a value of 6. So this attribute will give the number of sales our employee Ben has made in this week. Next, we need to identify the action that is being performed by the employee. Now by looking at the requirement which we have, we see that the action that is being performed is to achieve his weekly target. Now the actions of your requirement will be methods of your class. Methods are functions within your class that perform a specific task. Let's now create a method to check if the employee has achieved his weekly target. To create a method, use the def keyword just like how you would create a function, and then give a name to your method. Let's say has achieved target. Now you will notice here that I have made use of a self parameter. Now this is a default parameter that the methods of your class accept, and it is used in order to access the attributes of your class. Let's see how to access the attributes of your class by making use of the self parameter. Now let's assume that the employee needs to make at least 5 sales a week in order for him to achieve his target. So we will be having an if condition to check if the sales made this week is greater than or equal to 5. So that would be if, and to access this particular attribute, you need to make use of the self parameter in this way, self dot the sales made this week. Now I understand that at this point you might find the usage of self to be a bit confusing, but that's alright because in the next section we will be talking a lot more in detail about the self parameter. But for now, just understand that in order to access the attribute of your class, this is how it is done. So here you'll check if it is greater than or equal to 5, and if it is greater than or equal to 5, you have a print statement that says target has been achieved, and if it is not greater than or equal to 5, you would say target has not been achieved. So what you have done now is to create a class called employee and create 3 attributes and a method for that class, but none of these are accessible outside your class in your main program. So in order to access all of these attributes and methods of your class, you need to create objects for your class. Let's see how to create an object for your class. So you need to have a name for your object. Let's just say employee1 is the name of my object, and then you have an assignment operator followed by the name of your class with a set of open and close parentheses. So this is how you create an object for your class. And once you have created an object for your class, this object will have access to all the attributes and methods of your class. The process of creation of an object is also called as object instantiation. So let's see how to access the attributes and methods by using this object. So give the name of your object, which is employee1, and in order to access the attributes and methods, make use of the dot operator followed by the name of the attribute or method. Now if we want to access the name attribute, all you have to do is just write the name of that attribute, which is name, and that will return Ben. So our requirement was to check if Ben has achieved his weekly target or not. So now, similar to how you invoked the attribute name of Ben, you will now invoke the method has achieved target of Ben. So to do that, it is employee1 dot, instead of name, this time it would be the name of your method, which is has achieved target. And that returns the output as target has been achieved. Now let's say you're creating another employee. Let's call this one employee2. So now when you print the name of your employee, let's see what it returns. The name of your employee 2 is Ben as well. So this is not the right way to initialize attributes of your objects. When you have the attributes that are specific to each object, the way to initialize is different, and we have special methods that help us do that. And in the next section, we will be discussing about the methods and attributes in much more detail. Now before we move on to the next section, I want to fill you in with one more detail, which is everything in Python is an object. So what do I mean to say by that? Let's say you have a list called numbers with the numbers as 1, 2 and 3 as a part of your list. Now we have a function in Python called type, which checks the data type of your variable. Now if you check the type of numbers, you will see that it belongs to class list. Now list is a class that comes with Python, and what you have done now is to create an object for that list. So numbers is an object of your class list. So that's the reason when you perform operations on lists such as numbers.append, there is an append method as a part of your class list which performs this operation. So when I say numbers.append of 4, what happens internally is the append method of your list class is being invoked, and it updates your list as 1, 2, 3 and 4. So that's the end of this section. As a takeaway from this section, you now know what a class and an object is. A class is a blueprint, while an object is an execution of that blueprint. And then you learned how to create classes and objects in Python, and you briefly looked into the attributes and methods. In the next section, we will be talking a lot more in detail about the different types of attributes, the different types of methods, and we will also be talking about the self parameter that you're wondering about. I'll see you there. Thank you. Hello and welcome to the section on attributes and methods. In the previous section, you learned what a class is an object, and you briefly looked at what are attributes and methods. And in this section, you will be learning about the different types of attributes, which are class attributes and instance attributes, and then you will learn the different types of methods, which are static methods and instance methods, and then you will learn how to fully initialize an object by making use of the special method in Python called the init method. And you will also learn in detail about the self parameter, which we had seen in the previous section. So let's start with our first lecture, which is on class attributes and instance attributes. Let's get started by opening Python's idle environment. So what are class attributes and instance attributes? Now class attributes are attributes that are common to all the instances of your class, which means for every object of the class which you create, the value of a class attribute will remain the same. Now in the previous example in the section of classes and objects, we created an employee class and created 2 objects for that class, but both the objects had the same name of an employee. That's because what we made use of in those examples was a class attribute. Now what should go into a class attribute? Your class attribute should contain data which is common to all the instances of your class, and a name of an employee is definitely not something which should be a class attribute. Your class attribute could be something like the number of working hours, which could be common to all the employees in your company. So let's create a class called employee and then a class attribute called number of working hours and assign it with the value 40. So now let's create 2 objects for this class. Let's say employee1 and then another object called employee2. So now both your employee1 and employee2 should have access to the class attribute number of working hours, and that should return the value 40. Let's see if it works as expected. So employee 1 does have the value 40, and similarly employee 2 will have the value 40 as well. Yes, it does. Now what if you wanted to change this class attribute? What if you wanted to change the number of working hours to say 45? In that case, you need to make use of the name of your class and then access the class attribute. So the name of your class here is employee, and then use a dot operator and then the name of your class attribute, which is number of working hours, and and change the value to 45. Now if you try to access employee1.number of working hours, that should return the value 45. Yes, it does. And similarly, employee2 will return 45 as well. So now that you have understood what is a class attribute, let's next take a look at what an instance attribute is. Now a class attribute is common to all the instances of your class, while an instance attribute is specific to each instance of your class. For example, the name of each employee could be different. So let's see how to create an instance attribute. To create an instance attribute, you will make use of the name of your object. Let's say we are trying to create a name for our employee1 and then give a name for your instance attribute after a dot operator. Let's say the name of our instance attribute is name. And let's assign the name John to our first employee. Now when you try to access employee1.name, that will return the value John. Now let's see what happens if you try to access employee2.name. Now on accessing employee2.name, you have an attribute error that says employee object has no attribute name. That's because you created an attribute for your employee1 but not the name attribute for an employee2. So if you wanted to create a name attribute for employee2, you should be doing it similar to how you did for your employee1. So that would be employee2.name equal to, let's call the second employee as Mary. So now when you try to access employee2.name, that should return Mary. So now though both the name of the attribute is same, the value that is being held are different. That's because both of these are instance attributes which are specific to that particular object. Now what if you try to change the name of your class attribute by making use of the name of your object, which means instead of changing the value as employee.number of working hours, you'll try to do something like employee1.number of working hours and modify the value. Let's see what would happen then. So I'm trying to do employee1.number of working hours. Let's say I'm trying to reduce the number of working hours to 40. So now if I print employee1.number of working hours, that does return 40. So what you have done is reduce the number of working hours to 40. Now let's see if the same has been reflected on your employee2 as well, since you want your class attribute to be reflected across all the instances of your class. No, it did not. The value is still 45 for your employee2. So what happened in this particular statement here was you did not actually change the value of your class attribute number of working hours. When you use the name of your objects along with the number of working hours, what you just did here was to create another instance attribute called number of working hours with the value 40. So how Python accesses the attributes is, now for an object, when you provide the name of an attribute, it first goes and check if there is an instance attribute with that name. Now in case of employee1, you created an instance attribute with the name number of working hours and assigned it with the value 40. So when you said employee1.number of working hours, on checking for an instance attribute, it found that attribute and printed the value 40. Now for employee2, it first checked if there is an instance attribute with the name number of working hours. Now on checking, it did not find any instance attribute with the name number of working hours. And then it goes and checks if there is any class attribute by name number of working hours, and on checking for it, it finds a class attribute with the name number of working hours with the value 45 and it prints that value. So if you try to access something like employee1.age, what will happen is it first checks if an instance attribute called age is present, which returns false, and then it checks if a class attribute called age is present, which returns false, and then it throws an error that says employee object has no attribute age. So now that you have an understanding of what are class attributes and instance attributes, let's move on to our next lecture in which we will be talking about what is a self parameter. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, you learned what are class attributes and instance attributes, and in this lecture, you will be learning what is a self parameter and the reason why we use it. Let's start by opening a text editor. Now, if you have installed the Atom editor along with me at the beginning of this course, you can open that up, or you could use any text editor of your choice. Now let's first save this file as a Python file. Let me save it as self.py. And then what we will be doing in this program is to create a method for a class, and initially without the self parameter, and then we will execute it and see what happens, and then we will understand the reason why we need to go for the self parameter. So let's create a class called employee, and then let's have a method to initialize the details of the employee. So let me create a method called employee details, and initially I'm not going to pass the self parameter. Let's see what happens when we execute it. For now I'm not initializing anything. Let me just give a pass statement, which means to say that do nothing. So now what we will do is to create an object for this class. So let me just call my object as employee with the e in lowercase to differentiate it from that of my class. And next what I will do is use this object to call the method employee details. Now let's save this program and execute it to see what happens. So let's save it, and to execute it, if you're on Mac or Linux, you could use terminal, and if you're on Windows, you should be using command prompt and enter Python 3 space the path to your file name, and if you're on Windows, remember to use py instead of Python 3. Now my file is in desktop /self.py. Now on executing it, we have an error that says type error employee details, which is the name of our method, takes 0 positional arguments but 1 was given. Now here we might think that hey, something is wrong with Python. I never passed any parameters at the time of calling my function, it's empty. But then Python says that I have passed a parameter, so what's wrong? Now in order to understand what's happening, you should know how this method call is being handled by Python. Now though you are calling the method this way, the Python interpreter converts it into this. It uses the name of your class, which is employee, dot the name of your method, which is employee details, and then it passes the name of your object, which is employee. So that's the reason that Python was giving you an error stating that you had passed one argument whereas you have not received it in a function call. So this is the shorthand notation for this function call. Now both are valid statements, but this is a more commonly used style when it comes to a function call. So now let's go back to our method and make few changes. So now that we are passing a parameter, which is the object, let's receive it in the first place. So the first parameter which we receive will be the object, and by convention this parameter is called self. Now it need not be self, you are free to choose any name of your choice, but by convention it happens to be self because someone else, if they're reading your code or if you're reading someone else's code, when you look at this parameter called self, you will understand that it is referring to the object itself. Now in our method, let's give a name for our employee. So let's create an instance attribute called name. And how do we create an instance attribute? By using your object name dot the attribute name. So in this method, the name of our object is self, which is the object employee contained in the parameter self, and then enter a dot followed by the name of your instance attribute, which is name, and assign a value. Let me just call it Matthew. Now let's print and find out if it works as expected. So let me try if name is being printed as Matthew. So let's save it now and go back to our terminal and execute it. Now on executing, you see that this time the program worked without any mistakes, and you also see that it is being printed twice. The reason is because both these calls are valid function calls, and this is the more commonly used function call. So let's just get rid of this. This was just to show you how internally Python makes this function call. So now that you have understood the reason to go for self, you might want to try and find out what happens if you try to create an attribute without using the self parameter. So let's experiment that out. So if you are creating a parameter, let's say you're creating the age for your employee, and let's say he is 30 years old. Now let's print and check if it works as expected. So age equal to, that would be just age without the self parameter. Now let's save it and go back to our terminal and execute it to see what the output will be. The output is 30, which means you did not have any error. So now you might ask me, I got the output without using the self parameter, then why should I be using a self parameter? Now when you create create an instance attribute, your objective is for that particular attribute to be available throughout the lifespan of your object. Now, what do I mean by the lifespan of an object? It is the time your object is being created until the time it is being destroyed. An object destruction can happen when your program terminates or you manually choose to delete your object. So now if you want to check if your age attribute is available as long as your object is alive, it should be accessible in other methods of your object as well. Let's see if it works as expected. Now let's say we have another method. Let's call it print employee details. And here what we will do is print name and age. So let me first differentiate it from the other method. Let's just give a print statement that says printing in another method. And now what we will do is print the name and age of the employee. So when we print the name, and remember that we use the self parameter for the name, so that would be self.name. And then let's try printing the age of the employee. So that would be just age since we created it without the self parameter, and make a function call for it, which is employee.print employee details. Now let's save it and then go back to our terminal and execute it. So now on execution, you see that there is an error which is being thrown, which means to say that name error, name age is not defined in your function print employee details. So this means to say that this age attribute cannot be accessed within this print employee details method. That's because when you create an age attribute, you never used the name of your object. In order to create an instance attribute, you need to use the name of your object. So since you did not use the name of an object, the lifespan of this attribute is only within your method. So once your method terminates, this particular attribute cannot be used in any other methods. So I hope you now have a strong understanding on how the self parameter works. You might now have another confusion. What if my method does not need a self parameter? What if I'm not using any of the instance attributes? What if I just want to give a print statement to the user? Well, the answer to that is to use a static method, which will be dealt in the next lecture when we talk about instance methods and static methods. So as a review for this class, you have understood how to use the self parameter, how the parameter is actually being passed as your class name dot the method call in which your object is being passed. That's the reason that you use the self parameter. And you also understood what would happen if you do not use the self parameter along with the attribute, where the lifespan will be restricted within just that method. So I'll see you in the next lecture. Thank you. Hello and welcome to this lecture. In the previous lecture, you understood how the self parameter works, and in this lecture you will be learning what are static methods and instance methods. Let's get started by opening a text editor and saving our file as a Python file. Let me just name it as methods.py. So what are instance methods? Now, instance methods are methods of your class that make use of the self parameter to access and modify the instance attributes of your class. Now, all the methods that we have been using up until now are instance methods. Let's take a quick example to take a review of that. So that would be class employee, and then let's have a method, let's call it employee details, in which we will be initializing the name of the employee. By default, your method accepts the self parameter, and by making use of the self parameter, we initialize the name of the employee, and let's just call him Ben. Next, what we will do is create an object for this class, and using this object, we will be invoking the method employee details. So in order to do that, your object name, which is employee dot the name of your method, which is employee details. Now let's just print the name of our employee to make sure that the initialization has been successful. So in order to do that, just have a print statement in which you print the name of the employee, which is employee.name. So now let's save this file and execute it from our terminal or command prompt on whichever operating system you are in, and find out if this has been successful. So let's save it and open the terminal, and then enter the path to your file name, which will be in my desktop, and the name of your file. So that's python3 space desktop / the name of your file, which is methods.py. So now on execution, you see that the initialization has been successful and we have the name as Ben. Now what if we had another method that is used to display a welcome message to our user or to our employee? Let's just call the method as welcome message that accepts the default self parameter, and all that we have in our method is a print statement that says welcome to our organization. And let's let's call this method from our main program. That would be the name of our object, which is employee dot the name of our method, which is welcome message. Now by looking at our method, we see that we are accepting the self parameter, but then nowhere in the body of our method we are making use of the self parameter. Then what was the need to pass the self parameter? Now if we delete the self parameter and execute this program, Python will throw an error like how we had seen earlier. So the error would be that you have passed one parameter, but then while receiving it you haven't received it. So how do we handle this problem? Now this is where a static method comes into picture. Static methods are methods that do not take the default self parameter. So how will you differentiate an instance method from a static method? Now that's done by making use of a decorator called a static method. Now decorators are functions that takes another function and extends their functionality. They are denoted by starting them with an @ symbol. Now static method is a decorator in Python that takes the function welcome message and extends its functionality and ignores the binding of the object, and Python then understands that the binding has been ignored and it executes without any problem. So now let's save this file and execute it to see if it works as expected. So on executing it, we see that it has been executed with the print statement as welcome to our organization without passing the default self parameter. So that's the end of this lecture. You learned how to use static methods and instance methods. In the next lecture, you will be learning how to initialize the attributes of your class at the time of instantiation of an object by making use of the special method in Python called the init method. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, you learned what are static methods and instance methods, and in this lecture, you will be learning how to fully initialize an object by making use of the special method in Python called the init method. Let's start by opening a text editor. Let's first save this file as a Python file. Let me just call my file as init.py. Now in this example, what we will do is create our employee class with two methods. The first method will be used to enter the details of the employee, and the second method will be used to display the details of the employee. So let's get that done. That would be class employee. And then our first method, let's say enter employee details, which will accept the default parameter self. And then let's create an instance attribute called name and initialize it with the values, say Mark. And then let's create another method, let's say display employee details. So here what we will do is just print the name of the employee, which is self.name. Next, what we are going to do is create an object for this class. The name of my object, let me call it employee with the lowercase e. And then what we will do is, before we can call the first method, let's call the second method and see what happens. So in order to call the second method, that would be employee dot display employee details. So let's save this file and execute it from our terminal to see what happens. Again, if you're on Windows, you need to be using command prompt and entering py instead of Python 3. So the path to my file is in desktop/init.py. Now on execution, we can see that there is an attribute error that has occurred that says employee object has no attribute name. So what happened here was, when you invoked the second method display employee, when you tried to print self.name, the object was unable to find the instance attribute self.name. Now that's because we called the second method before we called the first method. The initialization happens in the first method, which we never called. Now we need to have a mechanism in which we can initialize all the attributes of our object or of our class before they are being used. Now Python helps us do that by making use of a special method called the init method, which is the first method that is being called at the time of your object creation. So let's create an init method and initialize the data attributes in that method. So in order to create an init method, the syntax is to have the define keyword, which is def, and special methods in Python start and end with 2 underscores. So your init method starts with 2 underscores followed by init and it ends with 2 underscores. So this is how special methods in Python are defined. And here what you will do is initialize your instance attribute, that would be self.name equal to Mark. And now since we no longer need this method, let me just get rid of it. Now let's see what happens. Let's save this file, go back to our terminal and then execute it. So now you see that we have got rid of that error and Mark has been printed. So let's go go back to our program and see what happened. So what happened here was, when you created this object called employee, the init method was invoked by default. So as soon as your object is being created, init method is the first method that is being called, and that initializes your instance attribute called name, which is being initialized to Mark. Now you need to make sure that you're initializing all your attributes within your init method. Now when you initialize all of your attributes with an init method, then your object becomes a fully initialized object, and when your object is fully initialized, you will not run into errors such as the one which we saw earlier. Now what if you wanted to create another object? Say you were creating employee2 equal to employee. Now let's call the display employee details for our employee2 and see what happens. So that would be employee2.display employee details. So let's save it and then go back to our terminal and execute our program. So as you can see, both our employee1 and employee2 has the name Mark. So we need to have a way in which our init method takes a parameter and then assigns the attribute with that parameter. So in order to do that, at the time of creation of an object, you can mention parameters within parentheses. So your employee1 can have the name Mark, and then your employee2 can have the name Matthew. In that way, when you call your init method, you can just pass a parameter. Let's say you're passing the parameter as name, and then assign your instance attribute with that passed parameter. So don't get confused with self.name equal to name. When you say self.name, you are referring to the instance attribute name, and when you say just name, you are referring to the name which you are passing in parentheses. So now let's save this file and execute it and see if it works as expected. So now going back to our terminal and executing it, we see that the first employee has the name Mark and the second employee has the name Matthew. So we have covered a lot of details in this section. Let's take a quick review on what we have covered in this section of methods and attributes. So we started off this section by discussing about what an attribute is. They are properties that further define a class, and then you learned what a method is. They are functions within your class that perform a specific task, and methods have access to all the attributes of your class. And then you learned what a class attribute is. Now these are attributes that are shared across every instance of your class. So if you modify a class attribute, it will be reflected across every object. So you can create a class attribute either by making it as a part of your class or outside your class by making use of your class name dot the attribute name. And then you learned what an instance attribute is. Now these are attributes that are specific to each instance of a class. So if you modify an instance attribute, that will be reflected only to that object and not on any other object. They are created by using your object name dot the attribute name. And then you learned how the self parameter is handled. When a method is being called, Python calls it as the class name dot the method name, and the object is passed in parentheses, which is received as the self parameter. And then you learned what an instance methods is. These are methods which accept the self parameter as the default parameter. They are used to modify your instance attribute. And then you learned what a static method is. Now these are methods that do not accept the default self parameter, but they can still be used to modify your class attribute. And then you finally learned what an init method is. Now this is a special method in Python that is invoked at the time of creation of an object, and it is used to initialize the attributes of your class. And when you have initialized all the attributes of your class within your init method, your object becomes a fully initialized object. So that's the end of this section. Go through the PDF notes attached and solve the exercise problems. I'll see you in the next section where you will learn about the first two pillars of object-oriented programming, which are abstraction and encapsulation. Thank you. Hello and welcome to the section in which you will learn about the first two pillars of object-oriented programming, which are abstraction and encapsulation. Now the reason why I have clubbed them both together in this single section is because they coexist. Now in order to understand what abstraction and encapsulation is, let's take a real world example. Let's say you're driving a car and you want to bring your car to a stop. Now as a driver of the car, the only thing that you need to be aware of is to apply the brake. You need not know as to what happens internally when you apply the brake. So applying brake is the layer of of abstraction that has been provided to you, and what happens internally has been encapsulated, which also means to say that it has been hidden from your view. Now in programming, you have been using abstraction and encapsulation all along, though you were not aware of it. The methods that you create which your objects calls upon, those were the layers of abstraction which you provided to the user. And in your class, when you write statements for your methods, that was the encapsulation that was being done. Encapsulation is done to achieve abstraction. Encapsulation is the process of hiding implementation details from the user. Now to give you an example that you might have come across, while using list, you must have used the append operation. So when you say your list name dot append and you provide a value, this value gets added to the end of your list. So append is the layer of abstraction that has been provided to you. You do not know the internal implementation of the append operation, which has been encapsulated in the list class. So to make sure that we have the understanding of abstraction and encapsulation right, let's take a look at a problem statement and solve it in Python by providing layers of abstraction and achieving it through encapsulation. We should implement a library management system which will perform the following task. The first task is the customer should be able to view all the books in the library. The second task is the process should be handled when a customer requests to borrow a book. And the final task is the library collection should be updated when a customer returns a book. So take a look at the problem statement. Before moving on to the next lecture, try to identify all the nouns, adjectives and verbs. Try to come up with a solution by providing layers of abstraction. Give a shot at it, try to solve it on your own. If you're unable to, no problem, we will be solving it in the next lecture. But before that, give it a shot. I'll see you in the next lecture. Thank you. Hello and welcome to this lecture. In the previous lecture, we had seen the problem statement. In this lecture, let's write a Python program to solve it. Now from the problem statement, we can identify the classes as library and customer. Now let's identify the layers of abstraction of each class. Our library class can have layers of abstraction such as to display the available books, to lend a book, and to add a book. Similarly, our customer class can have layers of abstraction such as to request for a book and to return a book. Now let's create classes to encapsulate all this data to achieve abstraction. So the first class which we create will be class library, and let's create methods for these class where we will encapsulate all the data. So the first method would be to display the available books. So let's just call it display available books. And for now, let's not have any data within the method. Let's just have a pass statement. We'll just write the skeleton of our program and then come back and later fill things up. And the second layer of abstraction was to lend a book. So let's just have a method for that. And thirdly, what we had was to add a book. Now let's create the skeleton for our customer class. So the layers of abstraction for our customer class was to request for a book and to return a book. So that would be request book and another method called return book. Now let's create objects for our library and customer classes. So that would be an object for library. Let me just call it library with a lowercase l. Similarly, let's create another object called customer with a lowercase c. Now at the time of creation of our library object, we want to initialize our library object with the list of available books. So what we should do is at the time of creation, let's pass a list of books to initialize it. So let's just keep the list short and have 3 books in the list. The first one would be Think and Grow Rich. And the second one, let's say it's Who Will Cry When You Die. And the third one in the list is For One More Day. Now when you're initializing this at the time of object creation, you should have an init method in your class which will initialize it for you. So now let's go back to our library class and define an init method. So that would be to define an init method and then accept the list of books which is being passed. And what we will do with this list of books is create an instance variable called available books and then assign it to that. Great, so now we have a library which has 3 books. Now let's display all these books in our display available books method. So now let's go back to our method. Let me just get rid of this print statement, and in order to print all the books, let's make use of a for loop. So that would be for book in self.available books. And what we will do is just have print statements that will print the name of the book. That would just print book. Let me just add few additional statements here. Let me just print a new line at the start of this method, and then let me have another print statement that says available book. Alright, so now our customer has a list of books from which he can choose a book to borrow. So now let's go back to our customer class and fill this method which is request book. So let's give a prompt to the customer that says enter the name of a book you would like to borrow. And then by making use of the input statement, let's take the input from the user. So that that will be stored in the instance variable called self.book, and then let's return that parameter or that attribute self.book. Now once the customer places a request to borrow a book, the library should be able to lend that book if that book is available, which means the book that is being requested by the customer should be accepted as a parameter in our lendBook method of our library class. So let's accept another parameter called requested book, which will be the book requested by the customer. And then what we will do is we will check if this requested book exists in the list of available books. So that would be if requested book is in the collection of self.available books, and if it does exist, we will give a print statement to the user or to the customer that says you have now borrowed the book. And once the customer borrows the book, we should remove that particular book from the list of available books. And to do that, let's call the remove operation on the list of available books. So that would be self.available_books.remove, and the book to be removed is the requested book. And in case the book is not available, we have an else statement that says sorry, the book is not available in our list. So we have now handled the process when a customer requests for a book. Now let's handle the process when a customer returns a book. So when a customer returns a book, let's give a prompt to the customer to enter the name of the book which he is returning, and then we will store this name of the book in an instance attribute called book. So in order to do that, let's make use of the input function, and then let's return this instance attribute self.book. So once the customer returns the book, this particular book needs to be added back to the collection of available books in the library, which means the add book methods of your library should accept another parameter called returned book, and all that it should do is it should add this particular book. So that would be your self.available_books.append the returned book to the end of your list, and then let's have a print statement that says you have returned the book, thank you. So now that we have completed the construction of all our methods, let's now provide a menu to the user whether he wants to display the available books or request or return a book. So let's add few print statements here. The first statement would be enter 1 to display the available books. The second option would be enter 2 to request for a book, and the third option would be enter 3 to return a book, and finally we can have another option that says enter 4 to exit. So this is the menu which we are providing to our customer. So now let's accept the customer's choice. So let's create a variable called user choice, and let's take input from the user, and then let's typecast this particular input to integer so that it is stored as either 1, 2, 3 or 4, which is an integer value. And then based on the user's choice, we will make our decisions. So that would be if the user choice is 1, you should display the list of available books. And how do you do that? By making use of the library object you call the display available books method. Now what if the user choice is 2? What should you do then? In that case, the user should request for a book, and when the user requests for a book, that should be stored in a variable. Let's call it requested book, and then let's make use of the customer object and call the request book method, and then we should let the library to lend this book. So let's call the library method or the lendBook method of a library, so library.lendBook, and then pass this particular parameter which is requested book. Now what if the user choice is 3? Then the user needs to return a book, so that would be return book and then customer.return book. And once this book is being returned, it needs to be added back to the collection, so that would be library.addBook, and within parenthesis we pass the parameter returned. And finally, if the choice is 4, we need to exit from the program, and that can be done by making use of the quit method. Now we want this menu to be active until the user presses the exit key. So in order to do that, we need to make this as a part of an infinite while loop. So let's run an infinite while loop and make all of this as a part of that infinite while loop. So now our program is complete. Let's save and execute it to see if it works as expected. So let's save this program and then open your terminal or command prompt to execute it. So that would be Python 3 if you're on Mac or Linux, and py if you're on Windows, space the path to your file name. I have saved it in desktop/library.py. Now we can see that a menu is being displayed to the customer. He can press 1 to display the list of available books, or 2 to request for a book, or 3 to return a book, and 4 to exit. So now let's press the key 1, which is to display the available books. So now the list list of available books are being returned. And now we can request for a book by pressing 2. So on pressing 2, we have the prompt that says enter the name of a book you would like to borrow. So from this list, let me borrow the book for one more day. So now we have the message that says you have now borrowed the book. Great. So now what we will try to do is we will try to borrow the same book once again to see what happens. So let's press 2 again and then let's enter the same name one more time. So let's enter for one more day. Now on entering for one more day, we have the message that says sorry, the book is not available in our list. Now that's because when you display the list, you can see that book no longer exists in this collection because it has already been borrowed by a customer. So now let's check out the third functionality, which is to return a book. So let's press 3 and then enter the name of the book. So now let's return for one more day. And now when you display the book, one more day will be added back to your collection. And then you can exit from this program by pressing 4, which will quit the program and break the while loop. So that's the end of this lecture. You have performed encapsulation within your classes and you have hidden all the implementation details from your main program, and you have only provided layers of abstraction by calling methods from your program, which gave you access to the data within your class. Hello and welcome to this section in which you will learn about the third pillar of object-oriented programming, and it is also the most commonly used one, which is inheritance. So what is inheritance? Now inheritance in real life is when you inherit certain characteristics and features from your ancestors. For example, your dad could be a really good baseball player. Now being his son, you too might have inherited his ability of playing baseball, and you yourself might be a good baseball player. Now inheritance in programming is no different. You will have a base class, or also called as the parent class, which will have certain attributes and methods, and then you will have a derived class, or also called as a child class, which will inherit these attributes and methods from its parent class. So your child class can have its own attributes and methods, and also it can have access to the attributes and methods of parent class. Now this reduces a lot of code by helping us in code reusability. Now in this section, you will be learning about the three types of inheritance, which is single inheritance, multiple inheritance, and multi-level inheritance. And also you will be learning what an abstract base class is. So let's start with the first type of inheritance, which is a single level inheritance. Let's start by opening a text editor. So let's first save this file as a Python file. Let me just name it as singleinheritance.py. So what we will be doing in this program is to create two classes. The first class will have a set of attributes and methods, and the second class will inherit these attributes and methods from the first class apart from having its own attributes and methods. So let's create a class called Apple, by which I mean to say the brand name Apple, and all the products that are being manufactured by Apple comes under the manufacturer name Apple Incorporated. So let's create a class attribute called manufacturer, which will have the value Apple Incorporated stored in it. Next, let's create another class attribute called contact website, which will have the website needed to contact Apple. So that would be contact website, and assign it with the value www.apple.com/contact. Let's now create a method called contact details, which will provide a print statement to the user with the details that are necessary to contact Apple. So we now have a class called Apple, which has two class attributes and a method. Now let's create another class, which will be a product that Apple manufactures. So one of the product that Apple manufactures is a MacBook. So what we will do in this class is make MacBook inherit the attributes and methods of the class Apple. In order to do that, all you have to do is, after the class name, within parentheses, enter the name of the class which you want to inherit from. Now since we want to inherit the attributes and methods from class Apple, in the class MacBook, within parentheses, mention the name Apple, and that will inherit the attributes and methods of the class Apple. Now here, the class Apple is called the base class, and the class MacBook is called the derived class. So now let's see how the class MacBook inherits the attributes and methods of class Apple. So let's first have an init method for a MacBook. So that would be define init and the default parameter self. And apart from inheriting the attributes and methods, MacBook class can have its own attributes and methods. So let's create an attribute called self.year of manufacture and assign it with the value, say 2017. And now let's have a method for our class MacBook. Let's call it manufacture details. So this method should provide the details of manufacture manufacturer, such as the year of manufacture and the name of the manufacturer. So let me just take in the default self parameter, and then we provide a print statement to the user that says this MacBook was manufactured in the year, and we have a placeholder for the year of manufacture, and then we say it was manufactured by and another placeholder for the name of the manufacturer. Now let's fill in those placeholders. So first it would be self.year of manufacture, and the next placeholder we need to fill in with the name of the manufacturer. So in order to access the attribute manufacturer, all you have to do is treat it just like any other attribute of your own class. So that would just be self.manufacturer. Now you would remember that when we spoke about class attributes and instance attributes, we spoke about the order in which Python looks for attributes. So first Python looks to check if this particular attribute is present as an instance attribute. Now when it finds it is not an instance attribute, it next checks if it is a class attributes, and then it finds out that no, it's not a class attribute as well, and then it goes and checks into your base class which you have inherited, which is the class Apple, and checks if manufacturer is present in the base class Apple. Now on finding that this particular attribute is present, that value is being fetched, and that is the value which will be printed, which you will shortly see when we execute this program. So now let's create an object for our class. You need to note here that we won't be creating an object for the class Apple. Instead, we will be creating an object only for the class MacBook. So let's create an object that would be MacBook equal to, let's instantiate the object, and then what we will do now is use this object to call the methods manufacture details as well as contact details. So the first method is the same like how you always do, since it is a method of your own class. So that is MacBook.manufacture details. And since now you have inherited the method contact details, the way you need to call the method is same as how you would call any other method of your class, which is by MacBook.contact details. So let's now save this program and execute it to see if our inheritance has been successful. So let's save it and open the terminal, and then enter the path to your file python3 space desktop slash single inheritance.py. Now you can see here that we have the output as this MacBook was manufactured in the year 2017, which is a attribute of our derived class, and then we have Apple Incorporated, which is an attribute of our base class. And then by making use of your derived class, you have called the method of your base class, which is the contact details method, which provided the print statement which you had given in your method. So that's the end of this lecture. You now know how to make an inheritance in Python. All you have to remember is to mention the name of your base class within parentheses while writing your derived class. In the next lecture, we will be talking about multiple inheritance. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, you learned what is single inheritance, and in this lecture, you will be learning what is multiple inheritance. So what is multiple inheritance? We spoke about you being able to play baseball by inheriting that ability from your dad. Now similarly, your mom might be good at cooking, and you might have inherited this ability from her, and you too might be able to cook well, which means you might be good at playing baseball, and also you might be good at cooking. Now similarly, in programming, a derived class can have more than one base class, and it will have access to all the attributes and methods of all these base classes. And let's take a look at how to implement a multiple inheritance Python. So let's first open a text editor and save our file as a Python file. Let me just name it as multipleinheritance.py. So what we will do in this program is to have three classes. The first two classes will be the base class of your third class. Let's see how that works. So let's have a class called operating system, and then let's have an attribute that says multitasking and assign it with a boolean value true. And let's have another class called Apple, and then have an attribute called website, which will have the website of Apple stored in it, that is www.apple.com. And now what we will do is create another class, let's call it MacBook, which will inherit features of both your operating system class as well as your Apple class. So that would be MacBook. The first class which you inherit will be your operating system class. And when you want to inherit more than one class, all that you have to do is to separate it with a comma. So now enter the name of the second class which you want to inherit, which is Apple. Now what happens is your class MacBook will have access to the attributes and methods of both both your operating system class as well as that of your Apple class. Let's see how that works. So let's define an init method for our MacBook class, and then let's make use of the attribute of our operating system, which is multitasking, to check if it is true or not. So that would be if self.multitasking, which is the name of our attribute, is true. Now if it is true, what we will do is just print a statement that says this is a multitasking system, and visit apple.com, which is a placeholder which I'm using now, for more details. And let's fill that placeholder by mentioning the name of the attribute which we have, which is website, and that can be accessed by self.website. Now let's create an object for our MacBook class and see if it works as expected. So that would be MacBook, and instantiate the object, and then let's save this file and execute it from our terminal to see if we get the expected output. So open your terminal and command prompt on Windows and enter Python 3 or py if you're on Windows, and that would be desktop/multipleinheritance.py. Now as you can see, since we have inherited the property multitasking, which was true, we entered into the if condition, and then we fetched this detail, which is apple.com, from our second base class Apple. Now what if both of your base class has got a common attribute? Say for example, your operating system has got an attribute called name, and let's say it has the value macOS, and your Apple has an attribute called name which has the value Apple. So what happens at the time of inheritance is both your base classes has got the same attribute. So when you use self.name in your derived class, what value does it contain? Let's find out. So that would be print, let's say name, and then self.name. Let's save our file and execute it. So you can see here that the name that was taken was macOS. So let's go back to our program and find out why that was. So why did it take macOS and not Apple? Now that's because it depends on the order in which we inherited. Here was the operating system class coming first and then the class Apple next. So if there is a conflict as the same attribute, the one from your first class will be taken. Now let's try changing the order of it. Let's say we are having Apple first and then we have operating system. So what do you think the output would be? As you guessed, the output will be Apple. Now there is another common problem which we will face when using multiple inheritance, which is commonly called as a diamond shape problem, which you will be looking at when we enter into the section of polymorphism. So that's the end of this lecture. You learned how to handle a multiple inheritance in Python. In the next lecture, we will be learning what is a multi-level inheritance. I'll see you there. Thank you.
Hello and welcome to this lecture. Now that you know what is multiple inheritance, let's take a look at what a multi-level inheritance. Now you are able to play baseball since you inherited it from your dad. But apart from that, you might have your own set of abilities. Let's say you're good at playing soccer. So now when your son inherits from you, your son will be able to play baseball, which you inherit from your dad, and he will also be good at playing soccer, which he has inherited from you. Now similarly in programming, we can have a series of inheritance. We have a class at the first level and another class at the second level. The class at the second level inherits from the class at the first level, and when you have a class at the third level that inherits from the class at the second level, the class at the third level will have access to all the attributes and methods to all the classes in the upper levels. Let's take a look at how to implement multi-level inheritance in Python. So let's first open a text editor and save this file as a Python file. Let me just name the file as multilevelinheritance.py. So what we will do now is to create a class called musical instruments, which will have some of the common properties that every musical instrument has. So let's do that. It's class musical instruments, and then a common property that musical instruments have is the number of major keys they have is 12. So let's create an attribute for that. And next what we will do is to create a subset for this musical instruments. So a subset of your musical instrument can be the string instrument. So let's create a class called string instruments. And now since it is a subset of musical instruments, it can inherit from your musical instruments class. So let's do that. And then let's create an attribute that is common for all the string instruments. Now all the string instruments are made of a type of wood, which is mostly a tone wood. So to fully implement a multi-level inheritance, let's create one more class which will be a subset of your string instruments class. Let's say the class guitar. Now guitar is a string instrument, and since it is a string instrument, it can inherit from the class string instruments.
So now that you have inherited guitar from string instruments, so what has happened now is guitar can access the attribute of string instrument, which is the type of wood. Now by looking at string instruments, you can see that string instrument has been inherited from musical instruments, which means your guitar class can also access the attributes of your musical instruments class. Now let's see how that works. So let's define an init method for a guitar class and let's give its own instance attribute. Let's say self.number of strings is 6. And then what we will do is print all of the attributes from all your 3 classes. So we'll print this attribute number of strings from the guitar class, the attribute type of wood from the string instruments, and the attribute number of major keys from the musical instruments to see how multi-level inheritance works. So that would be this guitar consists of 6 strings, which I'm just giving a placeholder for that. It is made of tone wood and it can play 12 keys. So let's fill all those placeholders up now. The first one is your number of strings, so that is self.number of strings, and since it inherited the type of wood, it can also have access to the type of wood, and since it is a multi-inheritance, it can also have access to your number of major keys. So let's now create an object for this guitar class. So that would be guitar and instantiate this object from the class guitar, and let's now save this file and run it from our terminal to see if multi-level inheritance is working as how we expected it to. So let's open our terminal, and if you're on Windows, open your command prompt and execute your file. So that would be Python 3 desktop multi-level inheritance.py. So as you can see, this guitar consists of 6 strings. So the number 6 is the instance attribute of our guitar class, and it is made of tone wood. The tone wood is an attribute of your string instrument class, and it can play 12 keys, where 12 is an attribute of your musical instrument class. So that's how a multi-level inheritance works. I'll see you in the next lecture where you will learn how to declare private, protected and public members in Python. Thank you. Hello and welcome to this lecture. Now that you know what is inheritance, let's take a look at what are access specifiers, which is a topic which we had left out from the section of encapsulation. Now in case you're coming from another programming language such as Java or C++, you might be aware of the access specifiers such as public, private and protected. Now in case you're not aware of them, let's understand what they are with the help of an analogy. Let's say you have some information on a sheet of paper and you're sticking the sheet of paper outside your house. Now this information is accessible by you, your family and to the people outside of your family. So in programming, when you make the members of your class as public, you're making them accessible to your class, to your derived class and anywhere outside your derived class. Similarly, if you are making your members protected, what you're doing is you're sticking the sheet of paper inside your house. Now the people who have access to this information is only you and your family members. So in programming, when you make your members as protected, it is only your class and your derived class that has access to this information. And finally, when you make your members as private, you're sticking the sheet of paper inside your room and you're the only person who has access to it, which means to say that they are accessible only by your class and not even by your derived classes. Now, while other programming languages forces access specifiers as a part of their syntax, Python does not do so. Rather, they are followed as a naming convention that has been practiced by developers over the years. The creators of Python have believed that if a developer needs to achieve something, the syntax of the language should not prevent them from doing so. Now, being a Python developer, you should be aware of these naming conventions. Let's take a look at what they are. Let's first understand the naming convention which is used to make the members of our class as public. Now by members of the class, I mean to say the attributes and methods of the class. Now making them public is what we have been doing all along until now. All that we have to do is just use the member name as it is without any changes. And next what we will see is the naming convention to make the members of your class as protected, which means to say that you're making them accessible only within your class and your derived class. Now the naming convention which is used for this is to start your member name with a single underscore. So that would be a single underscore followed by your member name. And finally, in order to make them private, what you will do is start them with 2 underscores and then the member name. So in order to make them public, just write the member name as it is. And in order to make them protected, you're starting it with a single underscore and then you enter the member name. By this, you're informing the other developers that, hey, just use this only within this class and within the derived classes and nowhere else. And by starting it with 2 underscores, you're telling the developers that use this this just within this class and nowhere else in your program. Now let's use all these naming conventions in a program. Let's create a class called car, and let's first create a public attribute. Let me call it as number of wheels, and since it is a public attribute, it will not start with any underscores. Let me just assign it with the value 4, and a public attribute should be accessible anywhere in the program. So outside the class, let's create an object and print this particular attribute outside. So let me just have a print statement that says public attribute number of wheels. Next, what we will do is to create a protected attribute. Now in order to create a protected attribute, it should start with a single underscore. So let's start it with a single underscore, and let's just call our attribute as color and assign it with the value black. Now a protected attribute can be accessed within our class and within its derived classes. So let's create a new class. Let's call this one BMW, which is a car, and so let it inherit from the class car. And what we will do here is in the init method of our BMW class, let's just print the value of the protected attribute color. Now let's create an attribute for our second class BMW, and then what we will do is before we move on to creating a private attribute, let's save this program and execute this one to see if it is working as expected so far. So let's save this and open our terminal or command prompt and then execute it. I have saved it in my desktop /access specifiers.py. So now on execution, we see that both the attributes are being printed, which is number of wheels and color. But one thing that you need to remember here is the protected attribute color is also accessible outside your derived classes. It is not syntactically forced, it is just a naming convention that is being used, and being a good developer, you should not use this particular attribute outside your family of classes. Let's now create a private attribute and see how that's being handled by Python. As I told you earlier, to create a private attribute, you need to start it with 2 underscores and then the name of your attribute. Let me just call the attribute as year of manufacture and assign it with the value 2017. Now let's try to access this particular attribute outside the class. So let me have a print statement that says private attribute year of manufacture, and let's use our object car dot the name of the attribute, which is year of manufacture, and then let's save and execute this program to see what the output will look like. So as you can see, there is an error that is being thrown that says car object has no attribute year of manufacture. So this is one of the strongest ways in which another developer is asking you not to use this particular attribute outside your class. But as I told you, the creators of Python have believed that if you need to achieve something, syntax of the language should not stop you from doing so. So now let's go back to our program and see how to handle this error. So when you start your attribute with 2 underscores, what happens is name mangling is being done to your attribute. So what do I mean by that? It means that the name of your attribute is being prepended with an underscore and the name of your class. So though you have saved the name of your attribute as 2 underscores and year of manufacture, internally how it is stored is underscore car and then the name of your attribute, which is year of manufacture. So that's the reason when you just said 2 underscores and year of manufacture, Python was unable to find such an attribute in your class car. So now in your print statement, if you start it with an underscore car and then if you try to execute your program, this should give you the output. So now let's go back to our terminal and then execute it. We have the output as 2017. Now though we were able to overcome this error, it is strictly asked not to do so until and unless we really have to do so. So these are the naming conventions that you need to follow when you make the members of your class as private, public and protected. That's the end of this lecture. Let's take a quick review on what we have learned in this section of inheritance. We started off this section by discussing about what inheritance is, which is the attributes and methods of a base class are being inherited by a derived class. Now this derived class will have access to the attributes and methods of the base class, and also it can have its own attributes and methods. And then you learned what a single inheritance is. Now this is when a derived class inherits from just one base class, and the syntax to define a single inheritance is to have your name of the base class within parentheses at the time of creation of your derived class. And then you learned what multiple inheritance is. Now this is when a derived class inherits from multiple base classes. This derived class will have access to the attributes and methods of all these base classes. The syntax to define a multiple inheritance is to separate the base classes with comma. And then you learned about multi-level inheritance. Now this is when a series of inheritance happens. You have a derived class which inherits from a base class, and this derived class becomes a base class of another derived class. So the derived class at the bottommost level will have access to the attributes and methods to its family family of base classes. And then you learned the naming conventions used for class members, which is just the variable name for your public member, an underscore, and the variable name for your protected member, which means to say this member should be accessed only within your class and your derived class. And then you declare private members by using double underscores, which means to say that this particular member should not be accessed outside class. And you learnt about name mangling, which is when you declare an attribute with a double underscore, it is being prepended with a single underscore and the class name. So that's the end of this section on inheritance. I'll see you in the next section where you will learn about the fourth pillar of object-oriented programming, which is polymorphism. Thank you. Hello and welcome to this section in which you will learn about the final pillar of object-oriented programming, which is polymorphism. So what is polymorphism? Now, by definition, polymorphism is the characteristic of an entity to be able to present in more than one form. Now let's understand this definition with the help of a real-life example. Consider identical twins. They both look the same, but they don't behave the same. And that's exactly how polymorphism works in programming. To give you an example from programming, in Python you must have observed that when you perform an addition between two numbers, their sum is being returned, but when you perform an addition between two strings, the concatenation of the strings are being returned. Now in both these cases, the addition operator looks the same, but it behaves differently. Now in this lecture, you will be learning the polymorphic property of overriding. Now to understand what overriding is, let's take an example from our previous section. We spoke about you being able to play baseball, but then you might not play baseball exactly like how your dad does. You might have your own custom style in which you will play baseball. Now overriding is when a derived class inherits methods from your base class, but then it might not behave the same way in your derived class. Your derived class has the ability to change the behavior of how this method works by redefining it in the derived class. Let's take a look at how overriding works in Python. So let's start by opening a text editor and saving our file as a Python file. Let me just name it as overriding.py. Now in order to understand the concept of overriding, let's take an example. Let's create our employee class and create two methods in it. The first method will be used to initialize the number of working hours of an employee, and the second method will be used to display the number of working hours of the employee. So let's create them both. So let me call my first method as set number of working hours. Now in this method, we will initialize the instance attribute number of working hours to 40 hours a week. And then in the next method, let's just call it display number of working hours. We will print the number of working hours which we had earlier initialized. So that would be to print self.number of working hours. Now let's create an object for the employee class and call these two methods to see if it works as expected. So that would be to create an object. Let's just call it employee with a lowercase e, and then by making use of the object employee, let's call both the methods. That would be set number of working hours, and then let's have a print statement. Now in case you're wondering what this end does, usually at the end of the print statement a new line character is being added, because of which every print statement starts at a new line. Now what you want to do is at the end of your print statement, instead of adding a new line, you're adding a white space character so that the number of working hours of the employee is being displayed in the same line. So now let's just call the second method, which is to display number of working hours, and then save and execute this program to see if it works as expected. So let's save it and open our terminal and run the program, which is in Python 3, and the path to your file name, which will be in desktop/overriding.py. Again, if you're on Windows, you should be using command prompt and using py instead of Python 3. Now we see that the number of working hours of employee is 40. Now let's create another class. Let's say we are creating a class called trainee. So what we want the trainee class to do is inherit all the attributes and methods from your employee class. And how do we do that? By using inheritance and inheriting the employee class within parentheses. So now what you want to do is, for your trainee, you want to set the number of working hours to 45 and not 40. So how will you do that? Now on inheriting, you have the access to these two methods, but then if you set the number of working hours, your base class will set it to 40 and not 45. So one option which you have is to create a new method in your trainee class and assign your number of working hours with the value 45. But if you do that, just think of it. You will be having a method called set number of working hours and a new method which you will be creating, which performs a similar operation, but then you don't actually need the set number of working hours. That results in a wastage of memory, and you don't want to do that. So the polymorphic feature of object-oriented programming comes with the concept called overriding, which lets you change the behavior of your base class method within your derived class, which means you can have the same name as that of your base class method. So in this case, it would be set number of working hours, and then you can have your own definition of your method within your derived class. So in this case, we can set the number of working hours to 45 instead of 40. So what you have done now is to redefine the method of your base class within your derived class. Talking technically, you're overriding your base class method. So now if you create an employee for the trainee class and set the number of working hours, it will set it to 45 instead of 40. So let's see if it works as expected. So let's create an object for the trainee class, and then by making use of this object, we will call the method set number of working hours. Next, what we will do is, by making use of the trainee object, you will call the inherited display number of working hours method. So before that, let's give a print statement. Let me just copy paste the same line, and then instead of employee, let me just have the print statement as trainee, and then the next line would be trainee dot we will call the inherited method, which is display number of working hours. Now let's save this file and execute it to see if the number of working hours for a trainee has been set to 45 instead of 40. So let's save this file, go back to our terminal, and then execute it. Now on executing, you see that the number of working hours of a trainee has been set to 45. Now what if for some reason you wanted to call the base class method set number of working hours? Now you see that on calling set number of working hours, your redefined derived class method is what is being called. But if you want to call your base class method, Python helps us do that by making use of the super function. Let's see what that is. Now in this example, let's say you wanted to reset your number of working hours back to 40. So in order to do that, you want to call your base class method set number of working hours. So let's see how to do that. Now let's create a new method. Let me just call it reset number of working hours. So in this method, what we will do is we will make a call to the base class set number of working hours, which will set the number of working hours back to 40. So in order to do that, let's make use of the super function. And once you call the super function, the control is being transferred to your base class. So if you say super dot, you can access any of the methods of your base class. So the method which we want to access now is to set the number of working hours. So that would be super dot set number of working hours. Now let's go back to our program and call the reset number of working hours method by making use of the trainee object. So that would be trainee dot reset number of working hours. Next, what we will do is to try and print the value of number of working hours to see if the number of working hours has been reset from 45 to 40. So in order to do that, let's just copy paste the previous print statements which we had, which is to print the number of working hours of a trainee and to call the display number of working hours method. So let me just make few changes here. That would be number of working hours of trainee after reset. Now let's save this program and execute it from our terminal and see if it works as expected. Yes, it does. So you see that the number of working hours of trainee after reset is 40. So what happened there was, in your method, by making use of the super function, you accessed the set number of working hours of your base class, which reset the number of working hours back to 40. So that's the end of this lecture. You learned the concept of overriding, which is to redefine the base class method within your derived class, and also you learned the use of the super function, which is used to access your base class method. I'll see you in the next lecture where we will talk about the diamond shape problem, which is caused at the time of multiple inheritance, and how overriding can cause a change in its behavior. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, you learned what is overriding, and in this lecture, you will learn how overriding affects multiple inheritance by taking a look at the diamond shape problem. So let's start by opening a text editor and saving our file as a Python file. Let me just name it as diamond.py. So in this example, what we will do is we will create 4 classes class A, class B, class C and class D. Your class A will be at level 1 and your class B and C will be at level 2, which takes a single inheritance from class A, and your class D will be at level 3, which will make a multiple inheritance from both your class B and C, thus forming a multi-level inheritance on class D, which can access all the attributes and methods of class A, B and C. So let's create our 4 classes. The first class would be class A. For now, let's just leave it empty. The second class would be class B, which inherits from class A, and let's leave this empty as well. And your third class will be class C, that once again inherits from class A. And finally, we have a class D that inherits from both class B and class C. So let's now create an object for our class D, which will have access to all the attributes and methods of all the classes A, B, C and D. So what we will do now is to go back to our class A and create a method. Let's give it any name of our choice. I'm just calling it method, and what this method will contain is just a print statement which will tell you which class was this method called from. So let me just enter the content of the print statement as this method belongs to class A. So what we will do next is take a look at 4 cases that can arise. The first case is we will not override this method in both class B and class C. The next case what we will do is we will override this method in class B but not in class C. The third case what we will do is override this method in class C but not in class B. And final case what we will look at is we will override this method in both class B as well as class C and see what the output will be. Let's see what happens. So for the first case, let's not override the method in class B and class C, which means you will directly call the method by using the object of your class D. So now let's save this file and open our terminal and see what the output will be. So let's execute this file, which is in Python 3 desktop/diamond.py. So you see that the output in this case is pretty clear. It says this method belongs to class A because this was not overridden in any of your derived classes. Now let's take a look at the second case. Let's try overriding this method in our class B. So in order to do that, what is overriding? You just redefine the method of your base class, so it will be of the same name with just the change in its definition. So let me just change the print statement. Let me say this time this method belongs to class B. Now let's save this file and execute it to see how the case 2 is being handled. So let's go back to our terminal and execute it. So this time you see that the method belongs to class B. So this was the method that was being invoked. So any time your method is being overridden, that will be the method which will be called through your derived class. So now let's look at the third case, which is to override this method in your class C and not in your class B. So let me remove this from my class B, and then let's have it in our class C with the print statement as this method belongs to class C. So now let's save this file and execute it. So as you can see, the method was overridden in class C, because of which this method was called. Now let's look at the final method, or the final case rather, in which we will see by overriding this method in both class B as well as class C and see how Python handles it. So now if we have the overridden method in our class B as well as in class C, let's see what happens. So we'll save this file, go back to our terminal and execute it. So in this case what happened is the output which we got was this method belongs to class B. So why did that happen? We understood how the methods were being resolved while we talked about multiple inheritance. It depends on the order in which you inherit in your derived class, which means if you have the class B first, the overridden method of your B class will be called first. If you have class C first, it will call the overridden method of your class C first, and this is called the method resolution order. So if you had to change the order from C to B, and now if you save this file and execute it, it should print that this method belongs to class C, and yes it does. So that's what a diamond shaped problem looks like. It depends on a lot of factors like in which derived class you're overriding in, the method resolution order of your derived class, and a lot of other stuff. So multiple inheritance can arise a lot of confusions, and it is best to stay away from it. So that's the end of this lecture. You understood what are the problems caused by multiple inheritance in a diamond shaped problem. I'll see you in the next lecture where you will learn how to overload an operator. Thank you. Hello and welcome to this lecture in which you will learn about the polymorphic property operator overloading. In this lecture you will learn how to overload the addition operator. Now earlier in this section we had discussed about the ability of the addition operator to behave differently in different cases. Now let's see how that's done. If you can remember, we had discussed about everything in Python being an object. So when you have an integer number, it belongs to the class integer. So when you perform an addition between two integers, in your integer class there is an add method which is defined, which knows how to handle the addition between two integers. Now similarly in your string class there is an add method which is defined, which knows how to handle the concatenation between two strings when an addition between them is performed. Now in this lecture you will learn how to write your own custom add methods, which is also called as operator overloading or overloading the addition operator. So let's first open a text editor and save our file as a Python file. Let me just call it overloading.py. So what we will be doing in this program is to create a class called square and then create two objects of this class. Now we will be creating the first object with the size 5 cm for all the sides and the second object with the size of 10 cm for all the sides. And then what we want to do is on adding these two squares, we want the sum of all the sides to be added for these two squares. So let's get started by creating a class called square. And then in our init method of this class, what we will do is initialize the side of the square. So that would be taking a parameter called side and then initializing your instance attribute side with the parameter side. Now let's create two objects for it. Let's call the first object as square1, and while instantiating it, pass the side of your square as 5 cm. And next what you will do is to create another square called square2, and then while instantiating it, you pass the side as 10 cm this time. Now what we want this program to do is the sum of sides of your square1 is 5 times 4, which is 20. Similarly, the sum of sides of your second square is 10 times 4, which is 40. And then you need a mechanism in which you can add this 40 and 20 and give the result to you as 60. Now there is a way to do this, which is to use functions and pass your parameters, but we don't want to do it that way. We want to use this feature of polymorphism and overload the plus operator in order to get this done. So eventually what our program will look like is when you print this sum of squares or sum of sides of both the squares, on performing your square 1 plus square 2, you should be able to get the result as 60. Now at this point, let's see how Python handles this particular step of adding square 1 plus square 2. So let's save this file and execute it from our terminal or command prompt on whichever system you're in and see what happens. So that would be python3 space the path to your file name, which is in desktop/overloading.py. So you can see here that Python throws an error that says unsupported operand types for plus, square and square, which means your plus operator does not know how to handle two objects of type square. So let's go back to our program and see what can be done. Now when you perform an addition between two numbers, your integer class has a special method called add, which knows how to add two numbers. Similarly, when you perform a concatenation between two strings, your string class has a special method called add, which knows how to concatenate two strings. But your square class does not have the special add method defined to add two squares. So that's the reason Python threw that error. So let's go back to our square class now and add a special method called add, which will add two squares and return the sum. So special methods begin and end with two underscores. So that would be two underscores, and the name of the add method is add and it ends with two underscores, which is how an plus operator is defined in Python. And this will accept two parameters, your square 1 and square 2. So let's take in those parameters, square 1 comma square 2. Now what you want this add method to do is to add the sum of all sides of both your squares and return that value. So let's have a return statement that does that operation. So that would be return 4 times your square 1 dot side, which will be 5 times 4 20 plus 4 times your square 2 dot side. So this will give you 4 times 10, which is 40, plus 20, and the result will be 60, which will be returned to your program. So now let's save it and find out if it works as expected. So let's open our terminal once again. Now you can see that the result that we have here is 60 because we defined a special method add, or rather we overloaded the add method to know how it should handle two square objects. So that's the end of this lecture. You learned how to overload an operator. You can overload any operators which you want. Just look up on the special name of your operator and that should do it for you. I'll see you in the next lecture where we will talk about what an abstract base class is. Thank you. Hello and welcome to this lecture. In this lecture you will be learning what an abstract base class is. Let's start by opening a text editor and saving our file as a Python file. Let me name it as abc.py, which stands for abstract base class. Now in order to understand the concept of an abstract base class, let's take an example. Say you wanted to write a program to compute the area of shapes such as square and rectangle. So let's first create a class called square and then let's initialize the side of a square. Say each side of the square is 4 cm. Next what we will do is compute the area of the square. So let's do that by creating a method called area and then let's compute the area within this method. So the formula to compute the area of this class square is side times side. So that would be self.side cross self.side, and let's just make this as part of a print statement which says area of square is self.side times self.side. Now similarly, let's create another class called rectangle. Now rectangle will have two sides, or rather two values, such as width and length. So let's initialize those values with width as 5 cm and length as 10 cm. And similar to the area function of square, we will have an area function in rectangle which will compute the area of a rectangle, which is obtained by width times length. So that would be self.width times self.length. So let's make this as part of a print statement. Now let's create objects for these two classes and check if it's working as expected so far. So that would be an object for square class with the name square and an object for the rectangle class with the name rectangle. And then what we will do is call the method area of square using the square object and area of rectangle using the rectangle object. So let's now save this file, open our terminal or command prompt and then execute this program. So that would be Python 3 and the path to your file name, which is in desktop/abc.py. So as you can see, we have the output as 16 and 50, which is the area of our square and area of our rectangle. Now by analyzing our program, we see that every class or every shape, be it square or rectangle, should have a method called area which is used to calculate its area. So how can we make sure that for every shape there is a method called area which computes the area of that shape? Now that can be achieved by making use of an abstract base class. An abstract base class is a class which does not have a definition on its own. It has abstract methods which forces the implementation in its derived classes. Let's see how that works. So for our classes square and rectangle, we can create an abstract base class called shape. Now in order to make this class shape as an abstract base class, you need to make this class as an instance of another class called ABC meta, which is available in Python. So in order to do that, you need to enter meta class, by which you mean to say that you're making the class shape as an instance of the class ABC meta. Now ABC meta is a class which has the properties of an abstract base class. So by entering this statement, you're making sure that shape is now an abstract base class. So as I told earlier, your abstract base class will not have a definition on its own. It will only contain abstract methods. So when you say define area, you're referring here that this method here in your class shape will not have a definition on its own, but it should have a definition in its derived classes, and you're making sure of that by making it as an abstract method. And how do you make that as an abstract method? By making use of the decorator called abstract method. So this abstract method decorator and the class ABC meta belongs to the ABC module of Python. So what we need to do is to import these two from that module. So that would be from the module ABC, you're importing ABC meta class as well as the decorator abstract method. Next, what we need to do is to make the abstract base class shape as the base class of your class square and your class rectangle. Let's do that by inheriting the class shape in your class square and the class shape in your class rectangle. Now what we will do is remove the function area or the method area from your class square and remove this line from here as well, and then execute this program and see what happens. Now note here that we have made use of an abstract base class that implements an abstract method called area. Now if this area is not defined in its derived classes, which is square, that should throw you an error. Let's see if it works as expected. So let's save this file, open our terminal and execute this program once again. So now on execution you see that there is an error on class square with abstract methods area. So that says which class has not implemented the abstract method. So now let's go back and fix it. So that would be to define the area in your class square, and then let's call the method in our main program, that would be square.area. And now let's save and execute this program to see if it works as expected, and yes it does. So now you have understood how to force your derived class to implement methods by making use of an abstract base class. Another thing that our abstract class lets us do is you can create objects for square and rectangle or any shape which you create. But does it make sense to create an object for the shape itself? Well, shape has to be something. It has to be either rectangle, square, circle or triangle or any other thing. But it should not make any sense to create an object for your shape. In other words, an abstract class should not be able to instantiate an object for itself. So let's try to see if we instantiate an object of the class shape, what happens. So that would be to create an object for your class shape, and let's execute it to see what the output will be. So as you can see, that throws an error that says cannot instantiate an abstract class shape. So that's because when you make a class as an abstract class, it will not let you instantiate objects for that class. An abstract class can only be inherited in its derived classes. So that's the end of this lecture. You've understood what an abstract base class is, and you've understood how to write abstract methods. Let's take a quick review on what we have learned in this section of polymorphism. We started this section by discussing what polymorphism is, which is the ability of an entity to be able to present in more than one form. And then you learned what overriding is, which is a form of polymorphism in which you redefine the method of your base class within your derived class. So what you will do in overriding is you change the behavior of your base class method within your derived class. And how do you do that? You make use of the same method name as that of your base class within your derived class, and you change the body of the method within your derived class. And then you learned what operator overloading is, which is you tell a particular operator to handle the operation between the objects of this class in a particular manner by defining the special method of that operator. And then you learned to overload the add operator by defining the special method add within your class. And then you learned what an abstract base class is, which is a base class which consists of abstract methods which are to be redefined within their derived class, and how to make a class an abstract base class by making that class as an instance of another class called ABC meta. And how do you do that? At the time of creation of your class, within parentheses you say meta class equal to ABC meta, and to make the methods of the class as an abstract method, we make use of a decorator called @abstract method. Now in order to use ABC meta and @abstract method, we need to import them from the ABC module in Python. So that's the end of this section on polymorphism. With this you have covered all the concepts of this course. Go through the attached PDF notes and solve the exercise problems. I will see you in the next section where we will implement a project based on all what we have learned. Thank you. Hello and welcome to the final section of this course. You have now learnt all the 4 pillars of object-oriented programming, and it's now time to make sure that you have your understanding right by implementing a project. Let's take a look at our problem statement. Let's create a project to simulate a banking system. You first need to provide a prompt to the user asking if they wish to create a new savings account or access an existing one. And if it is a new savings account that they wish to create, you need to accept their name and initial deposit, and then in your program you need to have a 5-digit random number generator, and this random number will be the account number of their new savings account. and if it is an existing account that they wish to access, you need to accept their name and account number and check if it's a valid user. And then you need to provide them options to withdraw, deposit or display their available balance if it is a valid user. Now before you move on to the next lecture where we will implement a solution for this problem, try to give an attempt at solving it yourself. It doesn't matter if it goes wrong, just try to give an attempt, try to identify what needs to be your class attributes and methods, implement all the concepts which we have learnt in this course such as abstraction, encapsulation, inheritance and polymorphism. I'll see you in the next lecture after you've given an attempt. In case you have any questions, put it up on the discussion board. Good luck! Hello and welcome to this lecture. I hope you have given an attempt at solving that problem, and if you have been able to successful at getting the right output, congratulations. But if you were not able to get the right output, then don't worry, let's see how to get that right in this lecture. So let's start by opening a text editor and saving our file as a Python file. Let me name it as banking.py. We will be dividing this solution into two different lectures. In the first lecture, we will be setting up our class structure right, and in the second lecture we will create objects for this class, and then we will execute this program and see what our output will look like. So let's start by first creating our class. From the problem statement we see that we need to have a class called savings account. Now the savings account class should provide layers of abstraction to the user. The user should be either able to create a new account or he should be able to access the existing account. So let's write methods for these two layers of abstraction to encapsulate them. So the first method will be to create a new account, and at the time of creation of the account, the user will provide you with his name and an initial deposit. For now, let's leave this method empty. Let's get the skeleton of our class structure right, and then we will come back and write all this code. Now, when a user creates a new account, we should have a way in which we can map his account number, his name and his deposit that he has made. So let's create a variable or an instance attribute in our init method which will keep track of all of that. Now in order to do that, let's make use of a dictionary. Let's call our dictionary as savings accounts, which will have the details of all the accounts that belongs to this bank, and for now let's keep this particular dictionary as empty. Now once the user has created a new account, he might want to access his existing account. So at the time of accessing existing accounts, we first need to authenticate if the user is a valid user. Now in this program we will be performing the authentication by taking the name and account number from the user and then matching that name and account number with the one which we have in our record. So now if these two matches, we say that the authentication is successful. So let's create a method called authenticate, and at the time of authentication, the user will provide you his name and his account number. And once the authentication has been completed, we should let the user to either withdraw, deposit or display his available balance. So let's write methods for all of that. Let's start with writing a method to withdraw the amount. So at the time of withdrawing, the user will enter a withdrawal amount, and then let's create a method to deposit. So at the time of depositing, the user will enter the amount that he wishes to deposit. And finally, let's have another method which is used to display the available balance. Now if you notice, any bank account should perform all of these operations. So how can we make sure that none of these operations are being missed out? We can make this class inherit from an abstract base class which will make use of all these methods as abstract methods. So let's get that done. Let's create an abstract class called account. And how do we create an abstract class? By making use of the meta class, which will make this particular class as a meta class or as an instance of the ABC meta class. And then we will make all of these methods as abstract methods within our abstract class. And how do we do that? By making use of the decorator abstract method. And since this will not have a definition on its own, let me just return 0 from this particular method. And similarly, let me just quickly make all the remaining methods as abstract methods. So we now have an abstract class with all of these abstract methods. Now in order to make use of ABC meta and abstract method decorator, we need to import them from the module ABC. Now let's make the savings account class inherit the abstract base class account, and by making use of the polymorphic property of override, providing, all of these methods are being overridden in our derived class. We now have the skeleton of our class structure right. Let's now fill all these methods with code. Let's start with the first method, create account. Now at the time of creation of an account, you need to generate a random 5-digit integer number which will be the account number for that user. So let's do that first. So let's have an instance attribute called account number which will hold a random 5-digit number. Now Python has a method called randint which will generate a random number based on the range which you pass. So we need this number to be a 5-digit number. So let's start the range from 10,000 and all the way up to 99,999. Now randint belongs to the module called random. So let's import this from the random module. So that would be from random import randint. Now this will generate a 5-digit number which will be stored in your instance attribute account number. Next, what we need to do is we have to map this account number, the name and the deposit of the user to our dictionary savings account. So let's do that. Now let's assign the key of our dictionary as the account number. So that would be self.savings account, and then the key of your dictionary would be the account number which you have just generated. So that is stored in self.account number, and then the values of your dictionary will be the name and the deposit value. So let's create a list. The first value will be the name of the user and the second value will be the initial deposit that's done by the user, which will be the balance of the user's account, which means our dictionary will be like this. When you call your dictionary's key with the value 0, that will contain the name of the user, and then when you call your dictionary with the value 1, that will contain the balance of that user. Now if the user is accessing an existing account, we should authenticate the user. And how do we authenticate the user? We first need to check if this account number that has been provided by the user exists as a key in our dictionary. So let's do that first. So if the account number that has been provided by the user is in your dictionary self.savingsaccounts.keys. Now if it does exist, next what we need to check is if the name contained in this account number is same as the name that has been provided by the user. So let's first fetch the name contained in this account number. And how do we fetch it? By making use of our dictionary, which is savings accounts, and then we pass the key, which is the account number that has been provided by the user, and along with that, to fetch the name, we pass the index as 0. So this returns the name, and then we check whether this name is equal to the name that has been provided by the user, and if they are equal, we say that the authentication is successful with the print statement. And once the authentication is successful, we can make this account number as the instance attribute for the rest of the process that follows. That would be to change self.account number as the account number that has been provided by the user, and then we can return true, which means to say that the authentication was successful. Now in case the name was not same as that provided by the user, we make a print statement that says authentication failed, and then we return a fail boolean value. Similarly, if the account number does not exist in the key of our dictionary, even in that case we return an authentication failure. Next, let's handle the withdrawal method. Now at the time of withdrawal, you first need to check if the amount that is being withdrawn is greater than the amount available in the user's balance, and if it is greater than the available amount, you need to let the user know that he has insufficient balance. So let's do that first. So you're checking if the withdrawal amount is greater than the available balance of the user. And how do you check the available balance of the user? You make use of the dictionary by passing the key as the account number which we earlier instantiated, and then by making use of the index position of 1, we obtain the balance of the user. And then what we need to do is, if it is greater, we need to let the user know that there is insufficient balance. And if the balance does exist in the user's account, we need to withdraw this amount and deduct this amount from his balance. So that would be to update your dictionary, so that's in self.savingsaccounts, and then obtain the balance amount, that's in self.account number with the index value 1, and then you're subtracting the withdrawal amount from this value, and then we can let the user know that the withdrawal was successful, and then let him know about the available balance which he now has. Now let's handle the deposit method. So in this case, all that you need to do is add this deposit amount which the user has deposited to the balance of the user. So that would be to update your dictionary savings accounts. We obtain the current balance by passing the index position 1, and to that balance we add the amount that has been deposited by the user. And once that's done, we can let the user know that the deposit was successful, and we can also let him know the available balance which he now has. And finally, let's write the display method, the display balance method. So in order to display the balance, all that we have to do is have a print statement that will let the user know how much balance he has in his account. So we now have filled up all the code for our class. Go through all this code once again, make sure that you understand each and every one of them right. In the next lecture, we will be instantiating objects for these class and then simulating this banking system. I'll see you there. Thank you. Hello and welcome to this lecture. In the previous lecture, we constructed an abstract base class and we inherited it in the class savings account. And by making use of overriding, we had overridden all the methods of our abstract base class, and then we provided layers of abstraction and encapsulated the data within these methods. In this lecture, let's create an object for our savings account class. Now, before we do that, there are a couple of changes which we need to make. The first change is to provide a print statement at the time of account creation, which gives the user his account number. Another change which we need to make is in our withdraw and deposit method. We have printed the available balance within these two methods, even though we had a method that does it for us. So the rule of thumb for a programmer is the DRY principle, which stands for do not repeat yourself. So let's get rid of this statement here, and then instead of printing it in this line, let's just call our method display balance. So since that's a method belonging to this instance, let's make use of the self object and then call display balance. Similarly, let's do the same for our deposit method as well. Let's remove the available balance from this statement and then let's just call our display balance method. Now let's instantiate an object for our savings account class and provide a menu to the user. So let me call my object as savings account with the lowercase s, and to instantiate it we make use of the class name with a set of open and close parentheses. Now the user can either create a new account or he can access an existing account. So let's give two print statements for it. First one is he needs to enter 1 to create a new account, and the second one is he needs to enter 2 to access an existing account, and then he can enter 3 if he wishes to exit from the program. Now let's make all of these statements as a part of an infinite while loop. Now let's read the user's choice as an integer input by making use of a variable, and now let's make decisions accordingly. So if the user choice was 1, it means the user wants to create a new account. So when the user wants to create a new account, he should enter his name and the initial deposit. So let's give a prompt to the user to enter his name, and then let's store the name in a variable called name, and next let's give a prompt to the user to enter the initial deposit, and let's store this as an integer value. And once this is done, let's make use of the savings account object to call our create account method. So that would be savings account dot create account, and then we pass the name and the deposit which the user has made. So now what if the user choice was 2? If the user's choice was 2, it means to say that the user is accessing an existing account. So in order to authenticate, we need the name and account number from the user. So let's give a prompt to the user to enter his name, and then let's also give a prompt to the user to enter his account number. Now once this is done, let's make use of a savings account object and call the authenticate method to check if the authentication has been successful or not. And while calling the authenticate method, we pass the name that has been provided by the user and his account number. So the authenticate method will return either a true or false. So let's store that in a variable called authentication status. And if the authentication status is true, we need to continue the execution with withdraw, deposit or display balance methods. So let's do that. If your authentication status is true, then you need to provide a menu to the user asking him whether he wishes to withdraw, deposit or display his available balance. So let's have print statements. He needs to enter 1 to withdraw, and he needs to enter 2 to deposit, and he needs to enter 3 to display his available balance. And then we can also have another option, which is to enter 4 to go back to the previous menu. Now go back to the previous menu means to say that he will go back to this menu here, which is to create a new account or to update an existing one. So let's make these as a part of an infinite while loop as well. Now let's read the user's choice. So if your user choice is 1, it means to say that he wants to withdraw. So at the time of withdrawal, your user user should enter a withdrawal amount. So let's store that in a variable, and then by making use of our savings account object, let's call the withdraw method and then pass this withdrawal amount. And if the user choice is 2, it means the user wants to make a deposit. So let's take an amount from the user, and then once again by making use of the savings account object, let's call the method deposit and pass the deposit amount which the user has entered. Then let's check if the choice made by the user is 3. If the choice made by the user is 3, it means the user just wants to view his available balance. So let's just make use of the savings account object and call the method display available balance. Finally, if the user choice is 4, it means the user wants to go back to the previous menu. So in order to go back to the previous menu, let's just have a break statement. And another condition which we need to check here is if your user choice is 3. Now by user choice, I mean to say the user choice which has been provided in the first menu. So in the first menu, if your user choice is 3, that means to say that your user wants to exit from the program. So let's just call the quit method, and let me just replace it with elif conditions for the first menu as well. So our program is now complete. Let's take a look at it from the beginning till the end to make sure that we understand what's happening. So when a user wishes to create an account, he enters his name and initial deposit, and then the create account method is being invoked. Now in the create account method, we generate a random 5-digit integer and make that as the account number, and then we store the name and the initial deposit to the dictionary by making use of the account number. And next what happens is when the user tries to access an existing account, he is asked to enter the name and account number, and then we call the authenticate method which will take the name and account number which has been entered by the user and check if that name and account number matches with the name and account number which is in our dictionary, and if it does, it returns a true status, and if it fails, it returns a false status. Now by making use of the true and false values which has been returned by the authenticate method, we decide whether or not to provide this menu to the user. So if the authentication status is true, we ask if the user wishes to withdraw, deposit or display the balance, and if he wishes to withdraw, he is asked for a withdrawal amount, and then the withdraw method is being called. Now in the withdraw method, we first check if the withdrawal amount is greater than the available balance. If it is so, the amount will not be withdrawn, instead a print message will be shown to the user. And if he does have enough balance, we withdraw the amount and deduct that amount from his balance. And on calling the deposit method, the amount which has been deposited by the user is added to his existing balance. And on calling the display balance method, his balance is being displayed. So now let's save and execute this program to see what our banking system will look like. To execute it, let's open our terminal or command prompt and enter python 3 space the path to your file name which is in desktop/banking.py, and if you're on Windows, enter py space the path to your file name. Now a menu is being displayed to us which asks us to enter 1 to create a new account or enter 2 to access an existing account. So let's first create a new account. Now we are asked to enter our name. Let's say we enter the name Matthew, and then the initial deposit which I'm making is $100. So now we have a message that says our account creation has been successful, and we are provided with our account number which is the random 5-digit number 25127. Now let's make use of the name Matthew and the account number 25127 and access an existing account. So that would be to enter the name as Matthew and the account number as 25127. So now we have a message as authentication successful. That's because the name Matthew and the account number matched with the one existing in the record. So now we can either withdraw, deposit or display the available balance. So first let's try the withdraw option. So on pressing 1, we can now withdraw an amount from our account. So let me try to withdraw $200. So now when I try to withdraw $200, I have a message that says it is insufficient balance. Now that's because when we enter 3, we see that the available balance which we have is $100. So since $200 is greater than $100, we have this message as insufficient balance. So now let's try another withdrawal. Let's say we are trying to withdraw $50 this time. So this time the withdrawal was successful and we have the message as available balance is now 50. Now let's try to make a deposit. So let's say we are trying to deposit $200. So now we have a message that says the deposit was successful and the available balance now is $250. So now we can go back to the previous menu, and then this time let's try to access an existing account. Let me enter the name Matthew, and instead of entering the account number which we first entered, let me enter a random account number. Let's say I'm just entering 123. Now this time the authentication failed, and that's because this particular account number does not exist in our record. So now we can enter 3 and that exits from our program. So that's the end of this project and our course. I hope you now have an understanding on the basic essence of object-oriented programming using classes and objects, and to give a good design to your program by making use of the 4 pillars of object-oriented programming. Let's have a short goodbye message in our next video. Congratulations on completing this course. I'm really happy that you've made it this far. You can get better at your skills only with constant practice. Not just programming, but any skills for that matter. So browse the internet, find some more projects of your interest and try to solve them. And remember, anytime you need my help, I'm available for you. You can reach out to me either through the discussion board or through a direct message. Please do share your ratings and reviews if you haven't already. That will help a lot of other people find this course. Thank you so much once again for being on this course. It was wonderful being with you. Until I see you in another course, this is your instructor Febin George signing off.